Hi everyone, welcome to our Tripoli 304 project presentation. We are group 4. Our group members are 43, 50, 51 and 61. Our project idea was to implement a 4-player quiz machine. As you know, during a quiz contest, the host asks some questions and the participants try to answer them. When a question is asked, the participant who presses the buzzer first will be selected for answering the question. If he can give the correct answer of that question, 1 point will be added to his scorecard. If he cannot give the correct answer, no point will be added and the host will move to the next question. This process will continue until we get the winner. Finally, the participant who gives the correct answer to a certain number of questions will be declared as the winner. We implemented this idea both in software and hardware, and here are the component lists we have used in our circuit.
This is the circuit we have designed in Proteus. Here we can see 4 push buttons for taking input from 4 players. Each push button is connected to an AND gate, the output of which is connected to the set pin of a D flip-flop IC4013. Since we need only set reset capability, we have kept the D inputs open. The output queue of each flip-flop is connected to an LED. This network of AND gates control the functionality of ensuring that only one player can answer at a time. In order to detect which player is answering at the moment, we have connected the input of the 7447 IC as per necessary logic. The push button here is connected to the reset pins of the flip-flops. To see how the circuit is working, let's say player 1 press the button first. This will force Q1 to 1 and the LED corresponding to player 1 has light up. This value is returned as long as reset pin gets no pulse. Since Q bar 1 is 0, the control output here is 0. Therefore, even if another player presses button, the output of this AND gate will be 0 and there will be no change in the circuit. At this moment, the display here will show 1, indicating that player 1 is the one answering now. Now, if we press the reset button, the input portion of the circuit will be reset.
After we have seen which player has pressed the button first, the player will be given a chance to answer. Our judge gets to decide if the player has given the right answer or not. If the player fails to give the correct answer, no points will be given, and we will return to asking questions again. If the player gives the correct answer, our judge will press the button attached to player 1, as player 1 has pressed the button first. So if we press this button, we can see that the 7-segment display output has been changed from 0 to 1, because after pressing this button, the clock pulse to the counter number IC74161 has been given, and from the outputs Q3 to Q0 through the 7-segment display decoder IC number 7447, the pulses have been sent to the 7-segment decoder. For fair justification, we have added a feature. If the judge mistakenly presses another button of another player circuit, say player 2, we can see no changes has been made. Or maybe player 3, no change, player 4, no change. And this has been done through the wires connected to the button and flip-flop output Q. As Q is 0 for all these conditions and only for player 1, Q is 1. Finally, whenever player reaches to 10, we can see the LED attached to player 1 has been on. This has been done by using this NAND gate IC7400. Now, if we press this button here, this will send a pulse to AMR of counter and the whole 7-segment display has been reset. Now we can ask another question and proceed.
In this video, we have shown the hardware implementation of our project. The blocks are arranged in the same way as in Proteus. In the left, there is the input segment. There are 4 push buttons. Each buttons have a LED in front of it. The red LED indicates player 1, the green one indicates player 2, and the yellow one is indicating player 3, and the white one is indicating player 4. In the input segment, whoever will press the push button first, the LED in front of him or her will be lit up. Meanwhile, if any other player tries to press the push buttons, their response will not be taken into consideration. So the first of the 4 players will be selected to get the answer. Here 2 separate power sources have been used. Each source is supplying 5 volt DC. The input segment is being supplied by a DC dry cell, and the output segment is being supplied by our laptop. Now let's assume that the third player has pressed the button first. So the light in front of him has been lit up. And if any other player tries to press the button after the third player, their responses will not be taken into consideration. If the third player gives the correct answer to the question, 1 score will be added to his segment. Here are 2 buttons. The button placed in the middle is the reset button, and the button placed in the corner increases the scores. Now before going to the second question, we have to reset the input segment. So after pressing the reset button, all the LEDs are off. So it's time for the second question. This time, say for example, the 4th player has pressed his button first. So meanwhile, if any other player tries to press the button and give answer to the question, their responses will not be taken into consideration. Now, if the 4th player can give the correct answer, 1 score will be added to his scoreboard. In this way, whichever player will give correct answers to all the 10 questions, the light placed in front of his scoreboard will be lit up. Therefore, we will know that he or she has passed that level successfully. So let's see how it works. We can see after adding 10 scores, the winning light of player 4 has been lit up. In the same way, if player 3 gets 10 points, the winning LED of player 3 will also be lit up. So this was all about our project. Thank you so much for your attention.